Hi, so today we'll be solving this question. Let T, which goes from R4 to R3, be a linear transformation given by T, which transforms this vector x1, x2, x3, x4, which is basically a vector in R4, to this vector right here, which is given by this equation 4x1 plus x2 minus 2x3 minus 3x4, and that's the first line, and those the rest of the lines. So this is a linear transformation which clearly goes from R4, which is this vector in this vector in R4, to R3, which gives this vector in R3. So now the question is which is asking for the range of T, which is this linear transformation right here, and they ask us to describe geometrically and then with a vector equation. So first we will describe this geometrically. So we know that any linear transformation given by Tx is equal to Ax, where A is an m by n matrix which when multiplied by x, which is also a vector, and is this vector right here, x1, x2, x3, x4, gives dx, which is this right here. And this is a vector in R3, hence a linear transformation from R4 to R3. So now whenever we have an m by n matrix A, which is just the coefficients of this equation right here, since a1 multiplied by x gives this, and so hence 4, 1, minus 2, minus 3 will be the first line of the matrix A. So if we write down the matrix A, which is a 3 by 4 matrix, 3 rows and 4 columns, we just take the coefficients of this right here. So A is 4, 1, negative 2, negative 3, 2, 1, 1, negative 4, and 6, 0, negative 9, and 9. So here we have A as a 3 by 4 matrix. So we know that whenever we have a matrix A in a linear transformation given by Tx is equal to Ax, and A is an m by n matrix, then the range of this transformation is basically in Rm. So here m is 3 and n is 4. So here Rm is R3. Hence, to describe the range of this transformation geometrically, we have the range of T is a plane in R3. So that is the geometrical description of the range of this linear transformation. So now, to find a vector equation. So to find a vector equation, we first have to row reduce this matrix right here, because the vector equation that we're trying to find is basically a linear combination of the linearly independent vectors in A. To find those, we have to first find the pivotal columns in A. So we have to row reduce this into RREF, even though even REF would work. So to row reduce this, we would actually get, which I have solved from before, a matrix 1, 3 by 8, 0, 0, 0, 1 by 4, 1 divided by 4, 1, 0, and 0, 0, 0, 1. So here we can see that the pivotal columns are the first, the third, and the fourth. So the linearly independent vectors in this matrix A would be 4, 2, 6, negative 2, 1, negative 9, and negative 3, negative 4, and 9. So to find the vector equation of the range of D, we will have to use this, and this column. So now we say if a vector B is in the range of this linear transformation T, then for some x1, x2, and x3 in R3, B is equal to x1 times its respective column in matrix A, which is 4, 2, and 6, plus, notice how we will not use x2 but we will use x3 since the second column is not a pivotal column. So the respective column of x3 is -2, 1, and -9. Plus x4 times its respective pivotal column, -3, -4, and 9. -3, -4, and 9. So this right here is the vector equation which describes the range of D for any B in R3. So here this spans a plane in R3, and when substituted for the values of x1, x3, and x4, could give a vector B, which is in the range of this linear transformation. Thank you.